Okay, so I think I'm audible.
Yes, sir.
Okay, great. So we are talking about the static random access memory. Let me start by creating the circuit of it. You please see this very carefully. I have taken initial circuit. I have told you that this is the inverter. The output of this inverter is to the input of this inverter. This is the circuit, right? I'll create the elaborated circuit of this and how this elaboration works. Let me make an inverter first. Now, this is an inverter. This is the other inverter. The sources of both NMOS are connected to ground and the sources of both PMOS are connected to VDD. You see, the output of this inverter is connected to input of this inverter and output of this inverter is connected to input of this one. So what I do is output of this inverter, I'll take some other color. Output of this inverter is connected with input of this inverter and output of this inverter is connected with the input of this. Now I give the name to this point as Q and to this as QB, right? So let us assume that Q is equals to 1. If Q is equals to 1, this Q is equals to 1 means it has a higher voltage. This higher voltage will go to the input of this inverter and this output of this inverter will become the lower voltage. And this output will become the input of this inverter and this will become the higher voltage. Now this is called just the storage of data. Can anyone tell me that if I name these transistors, let us name these transistors. This transistor is T1, this is T2, this is T3, and this is T4. Given with the present set of data, whatever data is being given, Q is equals to 1, Q is equals to 0, which transistors will leak the current? Which transistors will be responsible for leakage of current? Can anyone tell me? Out of T1, T2, T2, T3, T4, which transistors will be eligible for leaking the current?
T3 and T2.
Yes, it's T2 and T3. I told you in my initial classes that whichever transistors will be off, they leak the current. Now, if you see Q is equals to QB is equals to 0 is the input over here. PMOS is on the 0 input and T3 is off. Since T3 is off, that is why it will leak the current. You have one over here. This one will turn on T4 and turn off T2. If T2 is turned off, means it's an off transistor, so it will leak current. So T2 and T3 will be the current leaking transistors in this case. Please tell me if you have not got this even now, or is it clear to you that which are the current leaking transistors, right? So what we have assumed is, we have assumed that here you have Q and here you have QB, right? Now this is just called the storage of data. You have stored the data. Now after storing the data, you need to read it and write it. How you read and write? For reading and writing process, this is a 4 transistors. The industrial cell is 66 transistor SRAM. So where are the rest 2 transistors? The rest 2 transistors are here. This is called WL. This is called WL. Means same control signal on both transistors. And this line, which is connected with this external line, this is called bit line. And this is called opposite of bit line. We will see why this is called bit line and why this is called opposite of bit line. Now, you need to see this very carefully. We are going to talk about the read process. When we do the read process, it means whatever is data over here should be reflected on this. I repeat, the meaning of reading a memory means whatever the data is inside should be reflected on outside, right? So the data inside is Q is equals to 1, QB is equals to 0. We want this data to be reflected on bit lines. For this, for data to be reflected outside, what we do is we make both bit lines same initially. We have BL is equals to 1, BLB is equals to 1. What is the meaning of 1 means? 1 means initial values of these bit lines are high. Means we give high potential to these bit lines. High potential. When we'll do practical of it, I'll show you how do we get high potential to bit lines. For this high potential, giving high potential to bit lines, when you give Q is equals to 1 and you turn on this transistor with W is equals to 1, W is equals to 1. Now, initially, when your memory is in hold state, when it is only storing the data, this WL becomes 0. So it means this transistor is off, this transistor is off, your memory has nothing to do with the external world. It will keep on storing the data inside. But when you make this WL1, this means that now you want your memory to get connected with external world. When this WL1, BL is equals to 1, it is high potential. You have high potential here because Q is 1. You have high potential here. So means your transistor is on high potential from both sides. But what is the condition here? You have a high potential here, but QB is equals to 0, you have low potential here. And why do you have low potential here? Because Q is equals to 1 is giving high over here. This T4 is on. Please note the most important part of the memory during the read operation. When you have T4 as on transistor, when you have T4 as on transistor and your BL is equals to high potential, this is also on. So this BL will get a path. Which path? This BL, because current flow towards the high to lower potential. So you will get a path from this way towards the ground. Please let me know anyone who didn't got this. When I talk about BL is equals to 1, this value 0 is here, means this transistor is off. T3 is off. When T3 is off, your BL cannot find the path to get discharged. This is an open circuit. But when a transistor is on, it behaves like a short circuit, and your BLB will find a path like this towards the ground. I told you many times that whenever an NMOS is on, when there is high potential on the gate, it starts behaving as a short circuit. So this becomes a short circuit because WL is equals to 1. This becomes a short circuit. So your high potential passes through this, and your BLB actually comes down to low potential. Now you see your BL is on higher potential, BLB comes down to lower potential, BL is showing the value of Q, BLB is showing the value of QB. It means whatever you have inside the memory, now you have the same data outside the memory. This whole process is called read process of the memory, right? This whole process is called read process of the memory. When you have whatever inside the memory gets onto the outside the memory, that process is called read operation. Please tell me if you didn't got this, or if you still have any doubt about how we have read the memory. Please ask me, because I can explain the whole process to you again. The read operation means whatever you have on the data Q and QB, the same data should get reflected on BL and BLB, despite having the high potential on BL and BLB in start. हिंदी में बता दूं, BL और BLB स्टार्टिंग में दोनों हाई पोटेंशियल पे थे, पर क्योंकि QB 0 था, इसलिए BLB को एक लो रेजिस्टेंस पाथ मिला और BLB ग्राउंड हो गया. अब BLB पे वही पोटेंशियल है जो QB पे था, और BL पर सेम पोटेंशियल है जो Q पर है. जब अंदर का सेम पोटेंशियल बाहर BL और BLB पर दिखाई देने लगे, तो इसका मतलब यू आर डूइंग द करेक्ट रीड ऑपरेशन. when your data on Q and QB is reflected on BL and BLB respectively, then you are doing the read operation. Now please ask if you have any question till here, then I'll come to the write operation. Tell me if you have any question, any specific query. Okay, so I assume that now you understand what is the meaning of this read operation. So now I'll come down to the write operation. What is a write operation? Okay. For write operation, what does write operation means? Write operation means that you have some data outside and you want to change the data inside. You want to write the memory. Means you have Q is equals to 1. You want to make it 0. You have QB is equals to 0. And you want to make it 1. Right? You have QB is equals to 0. You want QB to be 1. You have Q is equals to 1. You want to make Q is equals to 0. How you will do that? Again, because we have the bit lines, so we will do this process through bit line only. You have, because you need some data from here to go inside, so you need to keep this WL high. Means you have to make this transistor become shorted, right? So what we do is, here Q is equals to 1. We want to make it Q is equals to 0. So here we give the lower potential. Here QB is equals to 0. We want to make it QB is equals to 1. So here I attach a high potential source which have the VDD is equals to 1 volt or whatever voltage you have taken, right? VDC over here. ये VDD होता है. So now what we'll do, we'll see what happens because your WL is equals to 1 in both cases. You will see that this transistor, let me name it T5 and T6. These are on, means these behave as short circuit. When these behave as short circuit and you have Q is equals to 1, then there you have zero potential, ground. So when this is a high potential, this is a short, and this is a lower potential. Your high potential will move towards a lower potential, and your QB is equals to 0, and this is 1. So this try to charge this bit from this side because this is short. This try to charge it. Now this QB will be charged to 1 only in case this transistor get turned off. When your Q is equals to 1 gets discharged from here, when it reaches the value VDD by 2, below VDD by 2 to be precise, this transistor get turns off. When this transistor get turns off, this potential easily get written to QB is equals to 1. And this is also supported by the fact that your Q get discharged means Q is moving towards 0 value, and this 0 will get as an input to this transistor, this inverter. When this inverter will have a 0 input, this will give 1 as output. So it gets two-way support. One support is from outside, one support is from inside, which is a 0. So this inverter actually gives 1 to the input 0. That is how now your data becomes from here Q is equals to 1 becomes Q is equals to 0, and this Q is equals to 0 becomes Q is equals QB is equals to 0 becomes QB is equals to 1. That is how your memory gets written. Please ask me if you have any doubts. This write operation is quite a bit typical. I know that it is not easy to understand this. So I'll try to explain this to you again. Many of you are not asking questions because you might be feeling tired since we had a long session today. But I want you to please understand only this thing. I'll make you understand the power, delay of memory, every part tomorrow. But please put your focus for once more to understand the right process. This is very important. If you do not get the right process here, then it will be very difficult for you to understand it further. So I'll try once to explain this to you. I hope you will get this. This is your latch. In your latch, I'll connect this output to this input and this output to this input. I'll name this as Q, name this as QB. Now I'll take the opposite values. Let me take Q is equals to 0, QB is equals to 1. Means when QB is equals to 1, this inverter, let me call it inverter 1, this is called inverter 2. Inverter 1 has input 1, inverter 2 has input 0, right? So now I'll connect excess transistors. Input is WL. Here you have VL, here you have VL bar. Now, because you have Q is equals to 0, you want to make it Q is equals to 1. So you will get something at higher potential this side, and you will give the low potential this side because you want to make 1 to 0. Now, because WL is equals to 1, right? Because WL is equals to 1, when WL becomes 1, the transistor, when the gate is at high potential, the transistor behave as shorted. So this transistor will behave as shorted. Assume that there is a direct wire. So there again, this is a short circuit. Assume that a direct wire. Remember, QB is equals to 1 means this bit is at higher potential. When this is short, the current will move from high to low potential. So this 1 will become 0, right? When this 1 will become 0, this 0 will get as input to here. When this inverter it will have the 0 input, it will give 1 output. So your 1 becomes 0 and 0 becomes 1. And since this 1 is here, this 1 will not be discharged because this again has a high potential here. It can be discharged only in case if you had ground here, which is not the case. You have VDD, so it cannot be discharged. Got the point? यहाँ पर Q भी आपका 1 था, वो 1 आपका ये शॉर्ट सर्किट देख के इट वेंट टू द लोअर पोटेंशियल. ये 1 से आपका 0 हो गया क्योंकि ग्राउंड में चला गया. जब ये 0 हो गया तो इस वाले इन्वर्टर को 0 इनपुट मिला इसके आउटपुट से. इसका इन्वर्टर का इनपुट 0 हो गया. जब इसका इनपुट 0 हो गया तो इसका आउटपुट ऑटोमेटिकली 0 से 1 हो गया. अब ये 1 डिस्चार्ज नहीं हो सकता बिकॉज देयर इज अ हाई पोटेंशियल. इट कैन डिस्चार्ज ओनली टू ग्राउंड. So this becomes 1, this becomes 0. That is how the memory write operation works. So there are three operations. One is the hold operation. In hold operation, your WL is equals to 0. One is the read operation in which your WL is equals to 1, but BL and BL bar are also equals to 1. Then your third operation is the write operation in which the value of BL and BLB will depend on your present state of Q and QB, right? WL is supposed to be 1, but the value of BL and BLB, BL will be equals to 0 and BLB is equals to 1 if your Q is equals to 1 and QB is equals to 0. And in this case, BL will be equals to 1 and BLB is equals to 0 if your primarily Q is equals to 0 and QB is equals to 1. That is how your memory works with these values. Tomorrow we'll do the simulation of these values. I'll repeat this whole process again to you and we'll see that how this memory actually works in simulations, right? So I think that's enough for the day. I've given you enough dose of the memory and I'll explain the things to you from tomorrow. How do we simulate the memory? We are left with very short time. That how do we simulate the memory? We are left with very short time because we have tomorrow. Then we may not have class Thursday on Friday, and then we'll have a class on Saturday. So I want this memory part. I want this memory part clear to each and everyone. Now, please ask if you have any question till here. Any random query that you feel like कि ऐसा नहीं होना चाहिए, ऐसा होना चाहिए. Please ask if you have any random query till here. Anyone, any question? Otherwise, I'll put all these recording to I'll give the recording link to you so that you can see that again and you can come back with the question. Remember, this memory is a very important part. All the companies you talk about, NXP, you talk about Micron, you talk about any other company, any random company, they ask about the question of the memory. In every research paper, you make an ALU or you make an any other micro architecture based circuit, you will require memory. So if you still have any doubt, you please ask. right? So let us stop here and we'll come back to the class tomorrow with the cadence based simulation, right? We had a long class today, so let's have some rest. Good night, everyone. And if you still have any question, you can put it on the WhatsApp. Thank you.